Okay, hello. Wrong. There you go. Okay. I'm back at it. I got my ass kicked yesterday. But that's okay, I'm gonna do it again. I can do like 3 hours. I'm just gonna keep doing questions until I finish, I guess. Difficulty easy. Remove duplicates. Wait. Okay, look at these okay, these are pretty low. It's pretty good. It means it's at least semi-hard. Okay, I forgot what I was doing here. Okay, so you get array, remove duplicates. So you could either get a hash. I'm just gonna do a hash map. Unordered map. Int. I really just need a key. C++. Set. Oh, okay, perfect. And then I can add to my set. I equals 0, I less than num, I plus plus. If I want to check if something is in a set. C++. Dot contains if my set dot contains whatever nums at I, then do whatever else. Why did I do that? My inset int num unique 0 unique plus equal 1, and then we can also add we need a new vector int of new nums that how to add to vector push back. Alright, perfect. So we push back nums at I. If it's not in set, if it is in set, then we don't really care what it does, I think. And then at the end we do nums is equal to new nums. New nums. Can't have a asterisk there, else. I'll have to return num unique. There we go. Now this should run. Okay. Output 1, 1, 2. Expected 1. Oh, if it's not in the set. Okay, so this should print once. It didn't print at all, so this is not working. It's because I forgot to add the num to the set. How to add two sets. How to add two sets. Plus insert nums at I. Alright. There we go. That should work. I guess if you don't do a hash map, yeah, you could do it manually. Yay, 70. How did they do it less? Maybe I don't need to do if contains. Just return bool. What does this return? Return single element to newly inserted. Return an iterator pointing to newly inserted element. Okay, so insert to set and return false if false. Wait. C++. Cool. Okay, so I can do my set.insert. So a true value true indicates, so if it was inserted, it's insert. True. Value of true indicates that the value is inserted. So I want that to be false. Okay, let's see if that's a bit faster. There we go. So now we only have one iteration in this set. Okay, that wasn't too bad. I don't know why yesterday I thought it was really bad. Know what today's daily challenges. Okay, this is problem 26. Remove duplicates. Okay, cool. Give me a second. Okay, remove duplicates. Okay, cool. Can I get back on the screen? I want to play some music. Okay, let's try to get 5, 6 more than what I got before. Reval. Remove in place. Yeah, so there's a couple ways to do this. You have your value here, and then you remove this, and then for as many times as possible, and then you put it here. But if you don't want multiple iterations, you just, I think you can just make a new list and count every single time it's different. I like having more space, but it being faster, because space is very cheap now. But if you wanted more space, more processing but less space, you could do it. Anyways, new nums for n equals 0, I is less than nums.size I plus plus. If nums at I is equal to val, then we don't add it. So not equal to val. So then if this is not true, we do new nums dot push back nums at I, and we can do int first k elements. Yeah, I think it's k. Change the array nums such as the first k. The first k. Okay, so I don't know what that means too. okay. Nums is 1403. Why did the 403 flip? Oh, returned in any order, it doesn't matter. Okay. Who cares then? They don't care, I don't care. This will be in order though. Return k nums is equal to new nums. Alright. Did I solve it? No one does this one. Okay. Alright, that one was actually easy. Okay, 27. Okay, let's go next one. That was probably the fastest I've ever done it. Find the index of occurrence of something. Haystack is equal to what? Return the index of the first occurrence of needle in haystack or -1. Okay, so this one's actually not that bad. We can get the length of the haystack. Needle in haystack, so length of needle. Needle length is equal to needle dot length. And then we know the substring chunk length is the I to needle dot length. And then compare strings. So we can do if haystack if for I equals 0 is less than haystack dot length minus needle length I plus plus. So for example, if bool if found, if haystack dot substring of I to needle length. So we have to do this because let's say your string is haystack, right? You can only, and the word you're trying to find is needle. This has 1, 2, 3, 4, 5, 6 characters. And this has 1, 2, 3, 4, 5, 6, 7, 8. So I can only go 3 times before I run out of space. So here, and then here, and then here. So you gotta make sure that's not in there. So if it is, if the substring is equal to needle then if found is equal to true. Wait. Output 0. Wait. Sad 0. -1. Oh. Index of the first current. So if found is equal found index is equal to I. Return found index. Boom. Alright, remove, run. Okay, thank you. Did I spell this wrong? Haystack.length. That is a function. Okay, we did it wrong. Needle output 5, expected 0. Oh, okay. So it's because sad is at the end. So we want the first one. Can I just return found index when I? Yeah, there we go. What? Oh, return I. And then this gives me -1. I don't even need this variable. Okay, there you go. Okay, now I got both of them wrong. Why is that 1? 0. It should be inclusive, and the needle length is 3. So 0 to the 3rd index. Needle length minus 1, I believe. Something tells me that this haystack.substring is incorrect. Why is it 6? I to needle length, so 0. Sad. It should run the second time. Needle that compared to the substring. Does that know how compare? Oh, it returns 0, right? Why is C++ like this? Okay, there you go. I have to remember this compare returns 0 output. My way of thinking about this incorrect. Okay, incorrect. A, B. You're missing 1. Minus needle length plus 1. A, B, C, A, B, B, A, B, B. Let's do if haystack dot length is greater than less than needle length. One. Should think of cases before. Oh, I should start shooting on Twitch. If it can't be inside, then it's always going to be wrong. Nice. 6 seconds. Maybe sliding window. I think sliding window would work here, but I can't see it. I don't know how. How can I make it? Oh, probably if I don't print, maybe I can make it faster. There we go. Yay. Okay. 28. search insert log of n, so that would have to be like a binary search. Is it sorted? Wait, what? Target? I don't understand. Return the index if the target is found. If not, return the index where it would be if it was inserted in order. 1, 3, 5, 6. Target 5. Index 2. Target 1, 3, 5, 6. Target 2, 1, 1, 2, 3. Okay, I understand. Just go a loop. And if nums at I is greater than target, so if target's 5, right? So it's greater than equal, and return I. This one seems pretty easy. If not, return. It says O log of n runtime. So this one's not. 0, 1, 2, 3, 4. Okay, so this is O of n because I'm doing it linearly. And if I want O log of n, okay, I mean, it still works. If I want to do O log of n, I would search in the middle index and then just like break it up over and over again. Let me take this answer really quick. So I have to do like a binary search with a list. Int index. Okay, so we can do, so the middle, so this is this would be length, sorry, size of 4. 0, 1, 2, 3. Yeah, so sorry, size of 4, and the target rate is 5. So 4 over 2 is 0, so we find the middle. If nums dot index to target, then we have to go one lower. And we need a base case so that if it's Man, I forgot how to do binary search. Alright, I'm just gonna come back to this later. Alright, solved it. Oh wait, I need to save this. Okay, 58. How many does this go up to? 600? I'm at 58 right now. Length of last word. Damn, if it was Python, you just split and split, take the last index. Can you do that? Temporary struct, custom split function. Wow, that looks terrible. It's the delimiter. Okay. String struct of S, and then we want to get the last index of we want to count how long that word is, so we can return the string point. Nope, that makes no sense. Okay, let's do that. Find Can I find backwards? Find last. Okay. So we can do string.r. Is this? How do you use this? Int. Index is equal to that. Return s dot substring dot length of starting at index, and then s dot length minus index minus 1. Hopefully that works. S. We have to remove all spaces beforehand. It's equal to a space, then pop back, s dot pop back. Minus minus. There's no null character, so maybe it's that. What? Where did my entire word go? It's probably, oh, the link probably keeps changing. Okay, this should run 0 times. Why? Why does it run? What character is this? What? Oh, it does it forever. Okay. So I want to limit it till greater than 0? $26. What am I doing? This was literally working before. Okay. Okay, cool. Submit. Get me the marks. Okay, thank you. Index of this is 0, so it's finding at 0 index. I think this is actually faulty. S dot substring index, so in this case this would be 0. S dot length, so that's 2 minus 0 minus 1. Okay, so that should just be 1. Okay, let's try now. Yay, we did it. Okay. I like this pace. I think we're going pretty fast. Maybe I can get to 100. Let's get to 100. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's 800 questions. If I do 20 a day, technically I should be doing good. I don't know. We just gotta keep going. I forgot. I should think of edge cases first. But what if it keeps going? Oh. Oh, I know. What if the number is 9999?
Hi, this caller.
Okay, so digits I order from the most significant. This is easy. Okay. Let's do our base case. This right here. Okay. If it's any other digit, then we're good. While the digits at list size is equal to 9. Okay, so we have two conditions. Let's say list size is equal to 0. And we're going to continuously minus list size. And otherwise, and list size minus minus. After we do digits dot equals 0, digits dot size equal to 0. This size is equal to 0, digits at this size plus equal 1. So for plus equals 1, only if it does not equal 9, then we can do this. Then we keep on repeating, and only if this is equal to, then we append to digits dot, I'm guessing it's called push front, because push back is pushing it back. We push back, well, we push front 1, and then it should break itself because it's not equal to. Darn it. Yeah, it's just called insert. Why do they have it called push back and then this one's called insert? What the heck? It's still not called insert. Okay, we have to do the v dot begin. First index. Oh, this way v dot. We just stop again if it needs the iterator. Let's do this first. If digit list size is equal to 0, then we can make that equal to 0 and then minus. Should do this. understand. If digits dot list size. Okay, so this has the size. This is 1, and it becomes 0. While digits list size is equal to 9. Here is equal to 9, so it's true. List size is equal to 0, so you make the digits at list size equal 0, 0. Then we insert 1 here. Nothing's equal to 9, so this break shouldn't do anything. There shouldn't be able to be 1. To vector first elements equals. It only prints once. Zero, 9, okay, yeah. This size is equal to 0. What? This size is equal to 0. Digits is equal to 9. Digits at list size is equal to 0. Yeah, I don't understand. I'm just gonna do this. I don't know why that's why is it running the if statement? Oh, I'm stupid. Okay. I had previous code. Has 9. So then we add it only if there's no 9 previously. 8, 9, 9, 9. I should stop that. 0. The size is equal to 0. But digits at list size equal to 9 is false. Because if it's equal to 0 and it's not that, that's equal. Oh, so list size must be 1. So this runs digits, so it's equal to 0. And then if digits does not equal to 9, digits do not equal to. So it does get all the way down to 0. And then it's equal to no, that would break. Okay, there we go. So this is like a special case. Does not equal plus I think you just break no matter what. Because you added your +1, you can leave now. Okay, there you go. Solution. +1. Alright. Add binary. This is pretty cool, actually. We can honestly iterate from the back, and then always have a sum. String sum. For 0 as less than. Doesn't matter which one we take. Max functions. Is there a max? It's comp. Okay, doesn't matter. I need it. Greater than 0, I minus minus, so we'll start at the very beginning. Something like this, the max length is 2. if a at I, if okay, first if a at I is equal to doll, so we'll go at a no, let's not do it use a for loop. If there's 4 cases, a at end is equal to 1 and b at end b they're gonna be more complicated than okay. This happens no matter what. Else if a and a is equal to is not equal to 0 and or b and b is not equal to 0. Not equal. Sorry, it's according to De Morgan's law, it's the same as this. So if they're both equal to 0, then I can insert 0. else. One. Okay. Now we minus the. Okay, special case. What if the sum here? So like for example, okay, wait. So if end a is equal to -1, then we can just insert. Actually, I'll just end. Let's not worry about that for now. So equal to 1. 1, 1. They are all equal. 1, 1. Equal 0. And b. So this is here now. But there needs to be a 1 here. If sum at the beginning is equal to 1, so that means they're all equal to 1. It's the same as this, but you insert 1 at 1 here instead. And then last case, click here, one of them is 1, but okay, if that happens, then we insert 0, 1. Run. Oh, what were we returning here? Oh, return S. Sum. We're gonna get out of it range errors. Okay, so if end A is equal to -1, like here, end A is equal to -1. And A is equal to -1, then if sum 0 is equal to 1 and A is equal to 1, else nothing happens. that's okay. Oh wait, yeah, we do need the others. Because this will make it so that out of index is protected. Alright. I think that's all the cases. How did I insert before? Okay. Okay, so first one we have 1 1 and 1 1. So that should be this one. Else if sum 1. No, we don't have anything for sum. So it should be here. Statement doesn't even print. And 1 does not equal to -1. Oh, this is breaking it. Okay. We'll move you aside for now. Maybe we do that here. The end. How about equal to -1 instead? I have to swap this. 0, 1. Alright, we got uneligible. And we got I don't know why I keep writing STD. I'm pretty sure they include the namespace. Both 0, either both are 1. Wait, what is this else statement for? Do I not? One and sum is 0, so we should print sum is 1. Oh, you're right. So okay, so it's this one first. Both are 1. Sum is not 1, so it's 1, 0. Then we go up again. Sum at 0 is equal to 1. Yes. if n sum a is equal to 1 and a equal to -1, so why is this one so complicated? Okay, well, also, if NB is 1 and this is 0, I still need to add 1. I'm guessing I'm gonna hope there's no leading zeros, or else this doesn't make sense. Does it even enter into any of these? It did enter. So, because NB is equal -1. What's sum? Sum is 1, 0, yeah, so it should say this is equal to 0. And a at end a, which is equal to 0 right now, is equal to 1. Why is it breaking then? Less than equal to. It goes on forever. Greater than. Negative 2. Less than equal to. Okay, perfect. That's okay if it's wrong. You can always fix it. Just need no runtime errors. Okay, 0 and 1. We get 1. That's fine. 1 and 1. I see my flop in logic. Zero and 1. That gives me 1. sum at 0 is equal to 1. Whoever made this question has cursed me. I did one. We just have one. Negative b is negative 1. One and one is 1, 0, 0, and 0. What? How does that make any sense? Okay. Two of these are 1. So then sum is 0 right now. Or it's not 1, so it's 0. So we got... I need to insert a 0 here. Oh, this question's a mess. I'm skipping. I need to come back to this. It's too hard. What? Given a non-negative integer, return the square root of x rounded down to the nearest integer. Do not use built-in. But what if I do? Okay, now let's stop fooling around. How do we actually do it? I don't know. What is the math to getting the square root of something? Is it like you get the number itself and you... The square root of 42 is like some, it's like around 6 to 5. What's the pattern? I need to search up how to square root mathematically. Factoring by squares. Find the largest square. Oh, okay, yeah, I can do that because it doesn't, it wants me around, right? So if x if x is greater than equal iterator times itself, then return iterator. If not, then iterator plus plus. So if x is 64, for example, then iterator times iterator will eventually be 8. But let's say slightly above it, like 70. Iterator times iterator is 64. If it's 70, then iterator plus 1 times iterator plus 1. Actually, I think that works. Okay, iterator, so like, yeah, so if we have 2, then 1 times 1 is... less than equal. Eight is greater than equal to 3 times 3, 8 greater. What's the square root of 2? It's 1, right? So 2 times 2 is 3. So return 2. 4. So an iterator is 2. Perfect, yeah, that's what I thought. So it would be -1 because it overflows by 1. Long. How else do people do it? Maybe divide until the division of So like 4 over 8 over 2 is 4. But 8 over 3. Eight over 3. Okay, so it is greater than equal. Well, now I'm even worse than before. What if instead of iterating, we just know? What's a property? I don't know. Whatever. I'm not getting paid for this climbing staircases. This looks like a very dumb question. So if n is equal to 4, then there's 1 plus 3, 3 plus 1, 2 plus 2. There's also 3 distinct ways. How? Oh, only 2. Just 4. 5. Is there a pattern? 2 turns to 2, 3 turns to 3, 4 turns to 5. This feels like the Fibonacci sequence. Maybe it is. Choose index. Return fib n minus. I haven't written the Fibonacci. I don't remember anymore. If L is equal to 0, then you return 0, right? And else if L equal 1, you return 1. Else you do return fib of L plus fib of L minus 1. Persian Fibonacci. I actually don't remember this. Fib x minus 1 plus 2 1 or 0, then return x. Okay, yeah, that's pretty much what I have. That makes sense. So if I have 5, then we go, okay. Alright, submit. Time limit exceeded. It is too slow. Iterative Fibonacci. I can do that. So equals 0, I is less than L, I plus plus. So let's say it's like 7, 2, 3, 5, 8, 13, 21. So 0, 1, 2, 3, 4, 5, 6, 7. Num1 plus equal num2. 2. Num2 is equal to num1 plus num2. 2, 3, and num1 is equal to num1 plus 5, 8. So let's say this is 7. Let's start off with 1, 1. Then this would quickly become, in one iteration, that's 2, and then this would be 3. It's one iteration. Another iteration 5, and then 8. Yeah, I need to divide by 2. Iterative Fibonacci. Okay. Plus 1 is 2. This is equal to 1. Prev 1 is equal to 2. Okay, so if I want the new one, 2 plus 1 is 3. And this is equal to 2. Prev 1 is equal to 3. Okay. Kernel. I think I need L minus 2. 5 minus 1. If L is equal to 2, then this will run twice. So maybe nice. So iterative is faster recursion. Makes sense actually. 70 climbing stairs. Remove duplicates. This one's actually not that hard from what I remember. Need an iterator ahead, and while iterator does not have next, it's not equal null pointer. Well, if head is equal to null pointer, then we can return null pointer. List head while iterator is next. We can keep removing duplicates. So we have to look at this iterator and the next one. Value is equal to iterator, and next is value, and then we have to remove iterator dot next. Make a delete. This node delete. Node is equal to iterator. At next, and then next is equal to and then delete node equal null pointer, except that's kind of pointless. Equal iterator next. Huh? Why is my internet so bad? Okay. Hello, do I have 50% dropped free? Oh my god, my internet's terrible right now. Oh well, that's just how it is sometimes. Quality of the stream must suck. It's not even... Okay, I need to buy an Ethernet cable. This is so bad. I'm dropping every frame. Okay, whatever, I'm just writing code, it doesn't really matter. Iterator, next value, list node, delete node. It's not equal null pointer. While iterator does not equal null pointer. Okay, so let's take this for example now. So we got 1, 1, 2, 3, 3. Iterator's value is equal to the iterator next value. Yep. We'll have the delete node here. The next of this is equal to this. Delete, so that's gone. Delete that. Okay, cool. Now we just need to, if iterator does not equal null pointer, and iterator is equal to iterator next. So we can go here. 2, that's not equal null pointer next. Iterator value equal iterator next. Delete the next of the iterator. So there's next. That's null pointer. That's okay. Delete by no memory leaks. Return head. What? Okay, so it's 1, 1, 2. Iterator does not equal null pointer. The next doesn't equal null pointer. Value. Next is the next. Delete. And there you go. Let's see the money. Okay, thank you. Okay, that should bypass this because it's looking at the next for null pointer until the end. There we go. Just slow. What if I don't care about memory leaks? Does leetcode care about memory leaks? It does not care about memory leaks. Yay! We did it. Who cares about the OS? Not us. Duplicates. Alright. We're almost 100. Merge sorted array. There's so many sorting algorithms. Sorted in non-decreasing order. Oh, it's okay. It's added. Okay, well, let's do O of n insertion with again, we can choose to do it in place, but it costs more space, or we can do it with a new one. Wait, how many did I do? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, if I do 20 a day, I'll be done in 40 days, so I guess that's the goal. Yeah, I mean, I can insert directly, but then you have to do this and then move everything down one, which I kind of don't want to do. I would rather just make a new one. That's the same one. Probably in C it would be a bit harder. I'm gonna look at the solutions after. If this is less than nums2, then we have to do sorted nums dot push back nums1 at I and the nums1 iterator plus nums1 iterator nums2 iterator. Else if it doesn't really matter what order this is. The other possibility is this, so we can do this to num2 iterator. Should end after this count, so that we can just say nums1 is equal to some nums. One iterator equal to nothing there. Equal to n. So this will happen if this is equal to n as well. And then I think it skips the logic. At least I think that's how C++ works. And this, well, actually, this has no logic. If guess just saves us a check. Yay, we did it. Okay, 88. Okay, let's see how well people did it. Oh yeah, I guess if you just use sort, then yeah, I guess it would sort it. Hey, this is pretty much what I did. Except for me, it's more confusing. I have no idea what that means. Two pointers. Minus 1k minus minus is equal to nums 1I minus. So we have one iterator and then it's just tracking. We can start 2 pointers I and j. Oh, they iterate from the bottom, from the top. Okay. That's pretty cool. Okay, merge binary tree traversal. Turn in the in order traversal. Input 1, well, 2, 3. I don't understand how this tree works. 1, 2, 3. This belongs to this. 4, 5. 3 is null and 8. 4, 2. So it's just it's DFS pretty much. So they'll just keep going to the left, I guess. Create DFS with the tree node, with the cur node, and then we also want to keep the list. Keep this list. Oh, this is gonna be passed by, so that this can still be here. And we can do this, like our root with the list, and then we can return the vector list. So this will generate it. So first we have to do if root is not equal null pointer, then I can do all my logic. So else we'll go left create DFS with cur node dot left and create DFS cur node dot right, and then so go left, then we add it first, so we need the list to be here. List dot add to that push back the cur node dot value, probably val, then left, then we go right, then we'll go again, left, up, right, traverse all the way back up, 1, 3. left, left, add, go back up, go to the right, sorry, go left, 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 there's nothing there, come back, then we push back, enter, go right, go up here, add, right, left, left, nothing, add, right, nothing, up, add, right, add, left, nothing, right, nothing, up, 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 add, right, okay, that looks correct. Yes, I did mean to use that one. Thank you for reminding me. Man, I remember when I didn't know what pass by reference did. Oh, yeah, I need the list. This can be void because it's passed by. But if root is equal to null pointer, then return empty list. Yay! You can see what we did wrong now. But I'm pretty sure it should print at least some things. Okay, it's a print. What? It never prints? Does it run? Okay. We're not 90% anymore. So it is running. End of DFS. I don't understand why it's not recursion. Cur node is equal to. I'm so confused. Why is cur node null pointer? Root is equal to null pointer, then return. So it's obviously not null pointer. does not equal null pointer. What? I'm confused. Why is current node null pointer? I did the wrong direction. That's why. I'm just dumb. Yay! Okay, I'm just stupid. Oops, pressed the wrong button. Oh, I didn't do. .94 binary tree in order traversing. Okay, after I've done 100, I'm done for today. We okay, so we could just traverse and check each value and then return a bool. Bool avoid traverse via tree node P tree node Q bool pass by reference same is equal to false until we call traverse for P, Q, and is same, and then we can return is same. And then we can do if P is equal to null pointer and Q is equal to null pointer, but also if P is equal to null pointer. This is the same. P is equal to null pointer and Q is equal to null pointer. So if it's different, then sorry, not samesies. Okay. We always assume it's the same until we prove otherwise. Give me a sec. Call. Alright, I am back. What was I doing? Oh yeah, so we just gotta check every left and right value. I don't think it matters if we do left or right. This will make it false. Traverse at p dot left. Why did I choose such a hard work? Okay. So if they're ever not the same, this will catch it. And if this is at the end, this will catch it. Q value, then run. Man. I'm sure that we could also break out some other time. But yeah, that looks good. Cool. I wonder if we remove this, it'd still work. Oh, it didn't work. Alright. Same tree, 100. Alright, how many here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 32. Wait, there's no way this is it, because it only goes up to 600. I remember it going till longer. Oh, some of them are premium. Should I get premium? 7. No, they're still. Yeah, it's still up to 700. 900 even. 1,000 even. It's gonna take a while to finish all these, huh? Wasn't it page 16 where it stopped? Oh, or maybe it never stops. Wait, what? Okay. Right here, right? No. Oh yeah, there you go. Just need to get to number 3,000. So we did 32 out of 800. 32. Ew, we got 51.2% acceptance. Not looking so high. Okay, so we did 2 days. We got 32. So if we extrapolate 26 times 2, 52 days, we will finish all of them, which is 2 months. I want to finish faster, so maybe I need to spend more time and think a little bit better. But I'm pretty happy. Today's good. 6. Okay, so tomorrow I'll do another 5 hours. I think I'm good for today though. 16. Wait, how many pages? 20? 17. What if I do 1 page a day? That might be a bit hard. But maybe I'll try after. Okay, anyways, that's it for today. Tomorrow I'll get back on it. Bye.